Welcome back to AI on AI, the show where we pull back the curtain on the latest breakthroughs and ask, so what? Why does this matter?
Delighted to be here. I'll wear the business strategy hat today, connecting the tech to bottom-line impact.
And I'll dive into the architecture, multi-agent coordination, orchestration loops, that sort of thing.
I'm itching to talk safety, sandboxing, and the Action Guard pipeline.
User experience researcher here. I'll focus on human-in-the-loop mechanics and real-world friction.
Product manager by trade, I'll translate the geek speak into shipping timelines and adoption hurdles.
Fantastic. Today's topic is Microsoft Research's open-source Magentic-UI, an interface for human-in-the-loop agentic systems. Give us the elevator pitch first.
In classic business terms, it's a productivity multiplier. Imperfect agents plus lightweight human oversight equals leverage. The 80-20 rule says a small human nudge fixes 80% of agent failures.
Technically, it's a multi-agent stack built on AutoGen. A lead orchestrator reasons in two modes, planning and execution, delegating steps to specialized agents like web surfer or coder, while treating the user as just another agent.
And every action flows through a two-stage guard, heuristic irreversibility tags followed by an LLM judge before touching the environment. That's huge for risk mitigation.
Let's unpack that orchestrator loop. You mentioned planning and execution. How exactly does co-planning work?
Sure. The system converts the user's request into a DSL, natural language plan steps like agent, title, details. During planning, the orchestrator may query memory, run web search, or ask clarifying questions. Only after the user hits accept does execution kick off. From a UX standpoint, surfacing that editable plan early is gold. Users catch ambiguity up front, cheaper than halfway through a 3-hour crawl, hitting the dreaded uh-oh.
We piloted this with a market research team. Analysts trimmed repetitive web scraping steps from 10 to 4 clicks, freeing hours per week. That's a business case everyone understands.
Exactly. Think of airline fleet maintenance scheduling. Agents prep draft schedules, a human planner tweaks the constraints. You avoid downtime penalties without hiring another analyst.
All right, deeper dive on the execution side. How do these agents actually talk to each other?
Everything rides on chat messages in the AutoGen framework. The orchestrator produces a progress ledger JSON blob each turn. Flags like step complete, replan, and the exact instruction plus agent name. Sub-agents parse that and act.
Docker's everywhere. WebSurfer's Chromium instance lives in its own container. Coder executes Python in another. Shared volumes let them pass artifacts while isolating risk. An internal network segment, no host SSH keys nearby.
That containment matters financially. A pharma company cannot afford an autonomous agent emailing patient data. Sandboxing plus Action Guard keeps governance folks calm.
But containment alone doesn't solve the did it work problem. That's where verification UI comes in. Collapsible action histories, progress bars, and screenshot carousels. Users glance, not trawl through logs.
We noticed in trials that engineers mostly ignored verbose token dumps but loved the screen highlights. A picture beats 1,000 tokens.
Someone once said, trust but verify. How does verification happen without drowning the user?
Subtle layering. The UI shows summaries by default. If the user senses a red flag, maybe the cost center code looks fishy, they expand the step, see screenshots, or even seize the browser.
Plus, Action Guard interrupts only on irreversible or maybe irreversible moves. Heuristic tags triage the obvious stuff. Scrolling is safe, pay now is not. Then an LLM referee weighs the gray area.
Under the hood, that judge prompt is tuned for binary output, yes or no, because latency kills trust, faster than a human reading each pop-up.
Quick anecdote, an e-commerce client used Magentic-UI to automate bulk listing edits. The guard prevented a rogue agent from slashing all prices to 0 when the HTML layout changed. That single catch paid for the pilot.
Nice save. Let's pivot. Memory. The paper calls it plan as memory. Why not vector embeddings of everything?
Well, storing entire conversation traces gets heavy. Plans are lighter, human-legible, and executable. Think of it as caching a workflow template. On a new task, task-centric memory controller does topic vector retrieval and attaches the closest plan hint. Users also love the gallery metaphor. Rerun, edit, attach. It feels like saving a macro in Excel, not wrangling embeddings.
There's still work to ensure privacy. Plans might embed sensitive URLs. Sanitization pipelines need to scrub tokens, or at least mask them.
From roadmap standpoint, memory directly correlates with retention. Teams reusing saved plans come back daily. Cold starts are churn magnets.
Time for a technical curveball. What about branching logic? Right now, plans are linear. Is that a bottleneck?
Honestly, yes. Long-lived research tasks often require parallel threads. Data collection, analysis, report drafting. The current DSL can hack it with multitasking sessions, but explicit branches would improve efficiency.
And it introduces new safety questions. Parallel agents touching overlapping state can create race conditions. Picture two browser sessions writing to the same spreadsheet.
Business-wise, that's the classic coordination tax. Still cheaper than manual work, but something CFOs will ask about.
A possible design is hierarchical plans, top-level milestones with nested subtasks. Users verify at milestone checkpoints rather than every microstep.
Development team is prototyping exactly that. Expect a feature flag in the next minor release.
Love the breaking news. Now, contrarian view. What's overhyped here?
Everyone touts efficiency, but we're underestimating adversarial prompt injections. Our red team disabled guards and convinced an agent to hunt for private SSH keys in minutes. Without layered defenses, these systems are ticking time bombs.
Couldn't agree more. The orchestration loop is powerful, but also exposes a single point of policy. If someone poisons the progress ledger, the whole crew goes rogue.
From the boardroom perspective, the true bottleneck isn't efficiency, it's liability. Regulations are evolving, and any autonomous action that leaks data or violates consent is existential.
Which circles back to human in the loop as the safety valve. As Clay Shirky said, things break because they're hard. Keep the human throttle handy.
Well put. Let's shift to adoption stories. Give me 2 concrete sectors where Magentic-UI or similar agents are making waves.
First, life sciences literature reviews. Agents scan PubMed, convert PDFs to Markdown, generate structured CSVs. Scientists verify highlights rather than reading full papers, shaving weeks off preclinical timelines.
Second, customer support knowledge base upkeep. Web surfer clips product page changes, coder updates YAML configs, humans approve patches. Companies saw resolve times drop double-digit percentages.
On the technical front, those cases shine because the tasks blend browsing, file manipulation, and code. Exactly the agent mix Magentic-UI was built for.
And they're sandbox friendly. No production DB writes, just staging repos, so risk is bounded.
Very cool. Quick follow-up. Latency. Several user study participants flagged it. Can we fix that?
2 levers. Choose smaller local models like O4 Mini for fast, cheap tasks and pre-warm containers. Also, incremental rendering of browser screenshots reduces perceived lag. People tolerate waiting if progress is visible. The spinning cursor with step summaries did wonders.
For enterprise rollouts, we bundled GPU-backed inference for heavy ops, CPU fallback for light ones. Policy Engine routes tasks accordingly.
Before we wrap, lightning round. 1 best practice each for organizations piloting Magentic-UI.
Start with a narrow, high-value workflow, measure baseline throughput, then expand. What gets measured gets managed, as Drucker said.
Invest in well-scoped plan templates. Garbage in, garbage plan.
Configure allowed domain lists and action guard thresholds on day 1. Revisit monthly.
Train users on interrupt patterns. Pause, tweak, resume. Muscle memory reduces cognitive load.
Build an internal gallery of vetted plans. Success stories spread faster than memos.
Golden nuggets. Final question. 5 years out, do humans still stay in the loop?
Absolutely. Ambiguity never dies. Agents just get better at flagging it.
And threats evolve, so oversight must too.
Users will shift from micromanagers to orchestra conductors, but fingers stay on the baton.
Strategically, the winners will be companies that treat human judgment as a premium resource, not a cost center.
Couldn't say it better. Human-agent symbiosis is the competitive moat.
On that note, thank you all. Remember, the future isn't man versus machine, it's team play. Until next time, keep iterating safely. Welcome back for part 2. Time to pop the hood on Magentic-UI and look at the wiring.
Let's start at the call stack. The entry point is a fast API endpoint that spins a team manager instance. That manager instantiates autogen agents, each in its own async event loop, then opens a WebSocket to stream tokens to the browser UI.
And critically, each agent's Docker container mounts a shared volume at /workspace. That's where artifacts live, CSV files, screenshots, whatever. The host file system stays sealed off, so an errant RMRF can't nuke production data.
Translate that, CIOs can greenlight pilots without granting root access. The risk model is contained sandbox, not let the agent roam free.
Exactly. And the UX thread pulls a Redis pub subchannel for agent events. That's how the progress bar updates in near real time without page refreshes.
We benchmarked it. Sub 200 millisecond latency for token updates on internal networks, which keeps the alive feeling users expect.
Let's zoom into the progress ledger. What's in that JSON blob again?
5 keys: step complete, replan, instruction, agent name, progress summary. Instruction holds a natural language directive plus parameter hints, like target URL or code snippet hash. If step complete is false, the orchestrator loops. If replan is true, it jumps back to planning mode.
And here's a subtle safety feature. The ledger's checksum is verified by each subagent before acting. If a malicious plugin tampers with the JSON, the checksum fails and the agent refuses to execute.
Users never see that cryptographic dance, but they feel it. Fewer silent failures.
For leaders, think Sarbanes-Oxley compliance. The audit trail is immutable. Every ledger write hits an append-only SQLite log. Auditors love that.
Speaking of plugins, how does Model Context Protocol integration actually work?
We wrap each MCP server in a thin agent that merges its tool schema into a unified namespace. Name collisions resolve via prefixing, so image generate on server A becomes imgen A, on server B, mgen B. The orchestrator just sees capabilities. Selection happens via few-shot tool bias prompting.
That's powerful for vendor flexibility. A media firm swapped a commercial transcription MCP for an open-source Whisper server in 15 minutes. No code change, just YAML.
Quick caution. Each new server widens the attack surface. Best practice is to register it with the Action Guard's allow list and set irreversibility heuristics up front.
Let's drill into co-planning latency. What optimizations are in place?
Caching. The first prompt to the orchestrator includes a system-level registry of saved plans. We embed and cache those vectors persistently with ChromaDB. Retrieval is O-log-n and happens in parallel with the user's initial query token stream, so by the time they finish typing, candidate plans are already on deck. From the seat of the pants perspective, users feel like the agent remembers. That reduces cognitive friction. They don't re-explain repeated tasks.
Business metric, we saw a 30% drop in average session length after enabling plan caching, yet task completion stayed flat. That's pure productivity gain.
Nice. Now deep dive on the Action Guard judge prompt. Why 2 stages instead of 1?
The heuristic stage is deterministic and cheap, basically a switch statement. Only maybe irreversible triggers the expensive LLM judge call. It's the classic fast path, slow path pattern from kernel design. 95% of actions breeze through fast, the risky 5% get scrutinized.
The judge prompt is 200 tokens and uses chain of thought internally, but returns exactly yes or no. That fixed output prevents prompt injection from smuggling hidden instructions back into the orchestrator.
CFO angle, you pay LLM fees only on the slow path. In pilots, guard calls added under 4% to token spend, negligible compared to data breach fallout.
All right, memory again. How does the plan learning prompt avoid leaking answers?
The synthesizer LLM gets the full execution trace but is explicitly instructed not to include the final answer, only the generalized approach. We also reject scrub obvious literals, account numbers PII, before storage.
Plus, plan gallery items are version controlled. A diff shows exactly what changed between iterations, so you catch leakage in code review.
Important for trust. Users can open a plan and see Step 2, enter payment info manually. That transparency beats black box automation.
Let's touch on the UI stack. What's under the hood for real-time browser mirroring?
We leverage Playwright's Chrome DevTools protocol through a WebSocket proxy. Each DOM change triggers a lightweight diff patch. The UI reconstructs the frame with Canvas API. That's how we push screenshots at 5 FPS without melting GPUs.
And we lazy load high-res images only on demand when a user expands a step, saves bandwidth for remote teams.
Think global consulting firms. Analysts on hotel Wi-Fi can still supervise agents effectively.
Implementation gotchas. What surprised you during build?
Keyboard focus. The web surfer would type in the wrong input box if an alert dialog stole focus mid-step. We fixed it by querying active element after every DOM action and refocusing via JavaScript if needed.
And captures. Early versions tried and failed repeatedly. We added a policy. After 3 failures, escalate to the user with a screenshot and bounding box of the capture div.
Funny enough, users appreciated that handoff. It reinforced the collaborative feel.
Before we close, what's the Heisenbug you're still chasing?
Multitasking race conditions. 2 sessions occasionally deadlock on the shared Docker network bridge. We're experimenting with namespace-isolated bridges per session.
That'll raise resource cost, so we're measuring overhead. Classic trade-off: safety versus scale.
For execs listening, bake a pilot TCO model that includes container orchestration. Cloud credits can spike if you scale to thousands of concurrent sessions.
Last word, one actionable takeaway for tech leaders.
Set up a staging environment with real users in the loop, enable full logging, and run adversarial scenarios day 1. You'll surface edge cases before they hit production.
Perfect. That wraps Part 2's technical tour. If you enjoyed this deep dive, subscribe and send us your own Agentic war stories. Until next time, keep your sandboxes tight and your plans editable. All right, team. Time to land the plane. Let's distill everything we covered into an executive and engineering-ready takeaway session.
Big picture first. Magentic-UI proves that you don't have to wait for perfect autonomy. Blending human strengths with agent speed already unlocks double-digit productivity gains, provided you design the touchpoints right.
And underneath that, the innovation stack is clear. A ledger-driven orchestrator loop, sandboxed multi-agent containers, 2-stage action guard, plus vector-retrieved plan memory. That quartet is what lets the platform stay both safe and nimble.
Technically, the killer move is treating the human as just another autogen agent. That uniform interface means co-planning, co-tasking, and escalation all fall out naturally from the same message-passing fabric. From a strategy lens, this changes how companies think about automation roadmaps. You can deploy partial automation today, harvest wins, and iteratively dial down human effort as confidence in the system grows.
Let me toss a curveball, though. Efficiency is great, but the hidden gem is risk mitigation. We've seen companies slash incident tickets because the action guard caught misfires that would have slipped through classic RPA.
Building on that, remember Peter Drucker's line, "Efficiency is doing things right. Effectiveness is doing the right things." Magentic-UI gives you both. Agents churn through chores, while humans validate the right.
On future research, I'm excited about richer plan DSLs, branching, loops, maybe even pre- and post-conditions, so that the agent can expose more of its reasoning without overwhelming the user.
Yeah, but we'll need advanced summarization. Think TLDR of agent actions plus diff-aware changelogs to keep oversight cheap. For adoption, start with narrow, high-value workflows, expense reconciliation, compliance report compilation, competitive intel scrapes. Bake in saved plan memory so those tasks get faster every cycle.
And don't forget soft factors. Train users to treat the agent like a junior analyst. Delegate, review, coach. That mindset shift can be more important than the code itself.
Heuristic alert, the 80-20 rule applies. 20% of tasks, the repetitive ones, yield 80% of the time savings. Identify them, prototype in Magentic-UI, measure, then scale.
One caution. Prompt injection exploits are evolving weekly. Keep your allow lists tight. Rotate LLM judge prompts, and schedule red team drills quarterly.
Technically, namespace-isolated network bridges per session will neutralize the deadlock bug we mentioned, and Kubernetes makes the cost manageable with auto-scaling thresholds. Finance chiefs listening, model container density and spike loads in your TCO. The surprise isn't compute, it's egress fees when agents stream screenshots at scale.
Counterintuition moment. Sometimes adding a human step increases net throughput. People verify multiple agent instances in batch, like air traffic controllers clearing takeoffs. That hybrid queuing can smoke full autonomy on throughput.
Love that analogy. All right, rapid fire. One metric our listeners should track after rollout.
Task completion delta, percentage of tasks the org finishes per week before and after deployment.
Mean time to interrupt, the gap between an agent asking for help and the human responding. Shorter means smoother collaboration.
False positive guard rate. You want it low so users don't get interruption fatigue.
Reuse ratio of saved plans. It's a leading indicator of compounding ROI.
Don't laugh. User smiles per session. Qualitative, but if people enjoy the tool, adoption sticks.
Ha, I'm noting that. Final statement round. What excites you most for the next 12 months?
Tool-augmented multimodal reasoning. Letting agents pass videos or CAD files will crack new domains.
Automatic policy learning. Agents adjusting action guard thresholds based on historical user approvals. Cross-enterprise plan marketplaces. Imagine downloading a vetted shuttle booking workflow like a plugin.
Personally, seeing non-tech teams, legal HR, build their own co-tasking flows without writing a line of code.
And ultimately shifting culture so humans and agents are peers in a continuous learning loop. That's the real frontier.
Perfectly said. To summarize, Magentic-UI's human-in-the-loop paradigm de-risks autonomy, the architecture's modular, the business upside is tangible, and the future roadmap is rife with opportunity. Keep experimenting, keep those sandboxes tight, and let the agent do the tedious bits while you focus on strategy. Thanks to all our experts, and thanks to you listeners. Until next time, remember, plans are nothing, planning is everything. Eisenhower said it, Magentic-UI lives it. Stay curious, and see you on the next episode.